In a race among 5 snails, there is at most one tie, but that tie can involve any number of snails. For example, the result of the race might be that Dazzler is first, Abby, Cyrus, and Elroy are tied for second, and Bruna is fifth. How many different results of the race are possible? So for this problem, we're going to use a bit of casework, and we're specifically going to use casework on the number of snails that get tied. So the first case, we'll call case 1, is if there are no ties. The second case is if there are exactly 2 snails that tied. The third case will be that there are 3 snails that form a 3-way tie. Case 4 will be similar if 4 snails are tied. Lastly, case 5, if all 5 snails tied. For case 1, if there are no ties, then this is just asking how many ways can we permute 5 snails. And clearly the number of ways we can do that is going to be 5 factorial, which is 120. Now, if 2 snails tie, then we need to choose which 2 of those snails are going to tie first, and the number of ways to do that will be 5 choose 2. Now, once I've chosen which 2 snails get tied, then this is the same problem as before, where I just need to rearrange 3 snails as well as a 2 snail tie. So altogether, I'm permuting 4 different objects, and the number of ways I can do that is going to be 4 factorial. So the number of ways under case 2 will be 5 choose 2 times 4 factorial, which is 10 times 24, which equals 240. Now the remaining cases can be done similarly. If there are 3 snails that are tied, then I need to choose 3 out of the 5 snails. That will form a 3-way tie. And then I need to rearrange 3 objects, namely 2 snails as well as the group of 3. This will give me 10 times 6, which is 60. Case 4 is going to be similar. We will get 5 choose 4 times 2 factorial. This equals 5 times 2, which is 10. Lastly, if there's a 5-way tie, there's only one way. So altogether, the number of ways, or the number of different results, is going to be the sum of the numbers that we obtained in each of these cases. If we add up the numbers, we will get 431, which is choice D.